Hello everyone, and this is Sandeep, and you are watching Samyans EduHub channel. And in this session, we are going to discuss about graphical representation of motion. So let us start now. So I am taking your one graph. Okay. So before plotting the graph, first you have to know what is x-axis, what is the y-axis. The horizontal line we called as x-axis, the vertical line we called as y-axis. On horizontal line, what we are taking now? On horizontal line, we are taking the time, and the vertical line we are taking the position. Okay. Now we are plotting the graph. Now you see, the graph starts from the zero, means your vehicle starts from the rest. After 1 second, it reaches to up to 20-meter distance. Next second, it reaches to another 20-meter distance, that is 40 meters. In third second, it reaches to 60-meter distance. In the next second, it reaches to another 20-meter distance. Like in every equal intervals of time, it moves equal distances. So this graph is example for the uniform motion. Okay, this graph is example for uniform motion. Why it is uniform motion? Why? Because in this graph represents equal distances in equal time of interval. So the object is moving in equal distances in equal intervals of time. So it is said to be uniform motion, right? Now, so when you plot the graph, so you have to consider all these points. So draw the axis. So x-axis, just you give the time. Y-axis, that is position, and this position time value give you velocity, right? The slope of this graph give you velocity. Slope means y-axis by x-axis. So slope of this graph, how do you define this slope? Slope equal to change in y-axis by x-axis. How do you get this slope? Okay, slope formula is slope equal to change in y-axis with respect to change in x-axis. Okay, so here on y-axis we have the position. Position means position, just you represent with the S2. Okay, position is the S2, so position is the change in position with respect to change in time. Okay, that is nothing but distance by time or displacement by time. So what it will give you? So this will give you velocity. Remember this, position of slope of position time graph gives you velocity. Okay, so from this also we can calculate the velocity. For example, you take any two values and get the velocity value. How do you calculate? Suppose I am taking your the position value here. Let us say this is a position 1 and position 2, and this is a time 1 time with respect to. You see, just you mark this. At 1 second, object is at 20 meter, right? At 4 second, the object is at 80 meter. Okay, so now you from these values we can find out the velocity. How do you find the velocity? So velocity equal to change in position, means 80 to 20, 80 minus 20 by 4 minus 1, time gap. Time gap is 4 minus 1. So that is 80 minus 20 is 60, 4 minus 1 is 3, that is 20 meter per second. Okay, then object is moving with 20 meter per second. So what it indicates? In each second it moves 20 meter distance, right? In every second it moves up to 20 meter distance. In each second it moves 20 meter distance, like that. So in equal time of interval it covers equal distances. That is, in each second it covers 20 meter distance. Okay, that is a velocity. Any values you can take, you will get the same answer, 20 meter per second only. Okay, so in this way we can find out the velocity. Now move on to the next graph. Okay, already we discussed this. So slope of position time graph gives you uniform motion. Okay, this constant velocity, this line, this constant slope indicates constant velocity, and the curved line indicates acceleration motion. Horizontal line indicates object is at rest. So what is the meaning of this? You see here. Now see, I am plotting the graph between the x-axis and y-axis. I am taking time value here and position value is here, right? If you are plotting the graph like this, if this curved line indicates non-uniform motion, means if this line turns or bends towards the position axis, what it indicates? It indicates increase in the speed, means your vehicle is increasing in the speed, means it is accelerating. Okay, the motion is accelerating, right? So the same graph when you plot between position and time, suppose you are getting like this, position graph versus time graph. So I am taking position on y-axis and time on x-axis. Suppose I am plotting the graph like this, I am getting like this horizontal line. Okay, so this line is parallel to the time axis. What it indicates? So your time is moving, but your position is not changing. Okay, your position is not changing means what it indicates? It indicates object is at rest. Okay, what it indicates? This is indicates object is at rest. And what this graph indicates? So in small time of interval, you're moving more distance. Means in small time of interval, your object is moving more distance. Means within small gap of time, your vehicle is moving up to more distance. Means your speed is increasing, right? So this line, this graph, when it is bent towards the position axis, your speed is increasing. That means you are accelerating. So what indicates? Accelerated motion. So this indicates accelerated motion, and this graph indicates uniform motion. Okay, remember all these points. It's a very important. Okay, so then move on to the next graph. Slope of position time graph gives you velocity. Already we discussed this. So in this example, they have taken the position 40 meter, right? So what they have taken here position they have taken here 40 meter, and another position they have taken here second position at 80 meter. So you see 40 and 80. So the time 40 related time is 2 seconds, and the 80 related time is 4 seconds. At 2 seconds object is at 40 meter. At 4 seconds the object is at 80 meter. So find the velocity. So slope of this graph gives you velocity. So y2 minus y1 means 80 minus 40 by x2 minus x1. So 4 minus 2, that is time value. Changing position with respect to the time gives velocity. 80 minus 40 is how much? Yes, that is 40 by 2. So 40 by 2 is 20. So that is what? 20 meter per second. The velocity is 20 meter per second. So just now we have calculated, okay, 80 and 20 I have taken, right? In these values also we are getting the same answer, that is 20 meter per second. Means this graph has constant slope everywhere. Any values you can take, you will get the same answer. 20 meter per second only. The slope is 20 meter per second, right? So here also 20 meter per second. Steeper the slope, higher the velocity. Steeper the line, faster the object. When comparing the two objects on the same graph. For example, I am taking two graphs here. Let us say, plot the two graphs. Let us say this is a car A. Okay, so another graph you take. This is a car B. Okay, in this, between these two graphs, which car is having more slope? The black line or this red line? Which line has more slope? The car A has the more slope. Okay, so which one has more slope? That one has greater the speed. The velocity of the car A is more than the velocity of the car B. Okay, so here velocity of car A. So velocity of car A is greater than. So velocity of car A is greater than velocity of car B. Why the velocity of the car A is more here? Why? Because the car A is moving with more slope. So the slope value is more. Okay, the velocity of the car also more. Okay, so the car A is moving faster than car B. Okay, for example, let us take another example. For example, here they have taken car A and car B. So in this same graph, I am plotting this. Let us take between position and time graph. I am taking three lines here. So let us take it's a car A, and another graph you take another one, that is car B. So let us take another value. Okay, that is car C. Okay, let us say this is the A value and B value and C value. This is car A, car B, car C. Now you tell, so which cars moves with more speed? And type your answer in comment section. Okay, I am waiting. Right, very good. The car A has more speed. Why? Because the slope of the car A is more than slope of the car B and car C. So which car moves faster here? The velocity of the car A is more The velocity of car A is more than the velocity of the car B, which is more than the car C. Okay, so the car A, the speed of the car A is more than speed of the car B, so which is more than car C, right? So in this way we can understand this. Now you see, so they have taken displacement or time. So displacement on y-axis and time on the x-axis. Okay, the A has less slope and the B has a more slope. Okay, so which one has more speed here? Object B has a steeper slope than A. That means here B has a higher velocity, right? So for the same time interval, B covers more displacement than A. So the car B is moving faster. That means it covers more distance, right, than car A. And intersection point where two lines cross, both objects are the same position at that instant. Suppose if two lines are crossing each other at that place, means when two lines cross equal to both objects are at the same position at that instant. For example, when you plot the graph like this, for example, you plot the graph, just a minute. Okay, so now, okay, so now you plot the graph. For example, I am taking two lines here. One is moving like this, okay, and for example, okay, you have to intersect, right? So the car A starts from here, it moves like this. This is a car A and car B, both intersect at one point. At this instant of time, and at this instant, objects are at the same position, right? At this time, the objects are at the same position. They are meeting it here, right? Like that. Now, move on to the next one, right? Velocity time graph. Now, just now we have discussed about the position time graph. Now, we are going to discuss about the velocity time graph. Shape tells the story. Horizontal line. Suppose, for example, here we have the two graphs, right? So, velocity we are taking on x-axis. Let us take here one example here. Okay. So, that means what it will indicate. You have to tell now. So, I am taking velocity on the y-axis, time on the x-axis. Okay. So, I am plotting the graph like this. So, what it will indicate? What it will indicate? The first graph, what it will indicate? The time is moving, but your vehicle speed is not changing. Your vehicle speedometer is not showing constant, so it is showing always constant value. It is not varying. So whatever the time it is, the speed value is constant everywhere. Okay, you are moving with constant speed means what it indicates? It indicates uniform motion. Okay, so if you are getting the a line which is parallel to the time axis for the velocity time graph, so what it will indicate? It will indicate uniform motion. The time is moving, but your velocity is not changing. Everywhere the velocity is showing the same value. So what it will indicate? It indicates uniform speed or uniform motion. Why it is uniform motion? Why? Because the velocity value is constant here, right? For example, in the second graph, you see that in the second graph, you observe the second graph. So observe the second graph. For example, when you plot the graph between the velocity versus time, okay, suppose you are getting like this. So what it will indicate? With increasing in the time, with respect to time, the speed also increasing constantly. Okay, in equal time of interval, the speed value also increasing equally. That means what it indicates? Your speed is increasing constantly. So that indicates uniform acceleration or constant acceleration. So what this graph indicates? Uniform acceleration. This graph indicates uniform acceleration. Why? Because you are with respect to time, your speed is increasing constantly. That means you are moving with constant acceleration. Okay, that indicates uniform acceleration. For example, in this case slope is increasing, means uniform acceleration. For example, if the same graph between velocity versus time I am plotting, velocity versus time. Suppose I am getting the graph like this. Okay, suppose when it is reaches to here, the velocity becomes 0, means your speed is decreasing. If speed is decreasing constantly with respect to time, what it indicates? Okay, what it indicates? It indicates decreasing velocity with constant acceleration. So velocity is decreasing. How it is decreasing? With constant deceleration. Okay, or constant deceleration. Acceleration is not good. Acceleration, when increasing the speed, you have to use the constant acceleration. But your speed is decreasing. Speed decreasing means that is decelerating. Your speed slowly decreasing. When it is reaches to time, your speed completely becomes zero. So it indicates decreasing in the speed with constant acceleration, that we called as a deceleration. Okay, or retardation, or also we called as retardation. Okay, move on to the next one. Right. Then what the slope of velocity time graph indicates you? Slope of velocity time graph indicates. So already you know the slope. What do you mean by slope? What do you mean by slope? Slope is nothing but change in y-axis with respect to change in x-axis. Change in y-axis means in the y-axis we have velocity's value, and the x-axis we have taken time t2 minus t1. Okay, change in velocity with respect to time, what it will give? Type your answer in comment section. Okay, so slope equal to change in velocity by time, what it will give? Yes, that is acceleration. Acceleration. Okay, next one we have your physical quantities which can be obtained from a velocity time graph. Okay, what are the physical quantities we can obtain from the velocity time graph? Okay, for velocity time graph, so when you consider when we discuss about the slope gives change in velocity by time. So change in y-axis with respect to change in time, or we can write as change in velocity by change in time. Slope is nothing but change in y-axis with respect to change in x-axis. In y-axis we have the velocity terms, and in x-axis we have time values. So this we can write v2 minus v1 by t2 minus t1. The slope of change in velocity by time, what will you get here? Acceleration. Okay, so this will give you acceleration. So acceleration is nothing but v2 minus v1 by t2 minus t1. Okay, then how do you find the acceleration from this graph? Let us take any two values you can take. So now you consider the two values here. Let us say this is at time t1 second. At time t1 second, the t1 is a 10. At 10 second, the velocity of the object is 5 meter per second. Let us take that is the initial velocity. Okay, at time 5 second. Now you consider the time t2. At the time t2, that is what, 20 second. At 20 second, the velocity of the object increases to 10 meter per second. Okay, you consider these two values and you find the slope of the graph that gives you acceleration. Okay, now you tell, let us say this is the v1, this is v1, and this is v2, and this is t1, and this is t2. Okay, so v2 minus v1. So what will you get here? v2 minus v1 is 10 minus 5 by t2 minus t1 is 20 minus 10. So from this graph we'll get 5 by 10, that is equal to 0.5 meter per second square. So this is what acceleration of the graph. Acceleration of this graph we got here 0.5 meter per second square. Okay, so in this way we can find out the acceleration. Now you see, by using the same velocity time graph, the area under velocity time graph gives displacement. Okay, so area is equal to the area enclosed by the line on the graph and time axis gives displacement. So area of the velocity time graph gives displacement. Okay, so you can write like this: area of velocity time graph means area under the velocity time graph. Area under the velocity time graph, area under VT curve or VT graph. So it will give displacement. Okay, so area means the line under this shaded region. Now you see, this is the line, this is the velocity time graph, right? Under this line, the shaded part, so this part, this area gives you displacement. Okay, from 0 seconds to 6 seconds we can find out the displacement of the object. Now this object is moving with constant speed, that is 20 meter per second. Okay, object is moving with constant speed. How we are saying the object is moving with constant speed? With increasing in the time, the value of velocity is not increasing, it is showing the constant value anytime, right? So that is showing 20 meter per second. So you take the area of this graph, area under this graph, that is what? Area of uh, area of OABC. Okay, area of OABC, it look like it's a rectangle. What is the area of the rectangle? Area of the rectangle is length into breadth. Here we can take OA into AB, OA into AB, or we can take OC into BC. Okay, so what is the length? OA value. OA value O to A. So how much it is? The value of O to A is how much? From here to here, 0 to 20. It will give the 20 value. OA value is the 20. What is the value of the AB? So AB value is nothing but this is the value. Sorry, OA value is the 20. AB value is the time value from 0 to 6. Okay. So A to B is nothing but AB value is matching with OC value. So OC means here 6. Okay, AB is 6. So 20 into 6, it is 120 meter. How you are getting the meter? The OA is the 20. So this is what? Meter per second. So this we can write as 20 meter per second. Okay, 20 meter per second into what is the value of the AB? That is 6 seconds. Okay, second get cancelled. 20 into 6 is 120 meter. Okay, the displacement covered during this 0 to 6 seconds of 6 second is 120 meter. Is it clear to everyone? Okay, right. Next one is how do you calculate the area from this graph? Okay, so you shade this part, the graph under AB curve. Okay, find the area under AB here. Area under AB. How do you find the area under AB? So you select this graph. This is the graph. Okay, from A to B, the area under A to B is showing the AE, BCDE. Okay, so my I want to calculate the displacement covered during this journey from A to B during 10 to 20 seconds. Okay, so find the area between 10 to 20 seconds. How do you find this? Now you see, this is a velocity time graph. Area under velocity time graph, what will you get here? Area under the curve, velocity time graph, under the velocity time graph, what will you get here? You will get displacement or distance. You will get here displacement. Okay, so this area we can classify it into two types. Okay, now can you tell what is the area it look like as? Trapezium, or here we have one triangle, one rectangle. Okay, so just you make this area into two parts. The first part is look like as triangle and the second part is look like as rectangle. Okay, so the total area, what is the area under this graph? A, B, C, D, E, A. Okay, this total area we can classify as two. Area 1, area of triangle 1 plus area of rectangle 2. Okay, so 1 indicates here the triangle, so this indicates triangle, this indicates rectangle. Okay, so what is the area of the triangle? Yes, that is half into base into height plus area of the rectangle. Already you know that is length into breadth. Okay, so now you tell which is base in the triangle ABC, which is look like as a base. Area of the triangle ABC, it is area of the triangle ABC and area of the triangle ACD. Okay, now you tell what is the area of the triangle, that is half into base into height, right? So when you consider the base is AC, okay, the height we can take here BC. Okay, now you take base is AC, half into AC into and height is BC, okay, plus area of ACD rectangle, you can take length and breadth. So length I am considering here ED or AC, anything you can take. So I am taking here ED length, and the breadth you consider here CD, ED into CD. Okay, now what is the value of AC? So A is showing 10, okay, she is showing 20. The difference between 10 and 20 is 20 minus 10 is how much? The gap is 10. Okay, so now you see the BC. So BC is the height. So this is the height. The C is at 5 meter per second, B is at 10 meter per second. The difference between 10 and 5 gives you the length of the BC. Okay, so 10 minus 5 is how much? 10 minus 5 is 5. 10 minus 5 is 5. Okay, plus ED into CD. Okay, so ED is the gap between 10 and 20, 10 second and 20 second. So that gives you 20 minus 10, that is 10. What is the CD? CD is a gap between the 0 and 5. Okay, CD is the gap between 0 and 5. The CD is the length of the 5 meter per second. Okay, so we can take here 5. Okay, so now just a minute. Now just you calculate this value. So what is the half into 10 into 5? So what will you get here? So 2 how many times? 5 times. So 5 into 5 is 25. 10 into 5 is 50. 25 plus 50 is 75 meter. Okay, so in this way we can calculate the area under the velocity time graph. So that gives you displacement. Okay, so what is the displacement during this journey from 10 second to 20 second from A to B? That is 75 meter. Okay, so the object moves during 10 to 20 second is 75 meters. Okay, with 20 meter per second speed. Like this you can calculate the area. Now we are going to discuss about the kinematic equations for motion in a straight line with constant acceleration. So if object is moving with constant acceleration, what do you mean by constant acceleration? Constant acceleration means increase in the speed. The speed is constantly, it is increasing. Okay, so when there is no change in the speed, there is no change in the speed. If speed is constant, in case of uniform speed, consider the acceleration value is 0. Why? Because if speed is not varying, if speed is constant, in that case acceleration becomes 0. If speed is increasing constantly with respect to time, in that case we can consider the acceleration. In that situation only we can consider these 3 equations of motion. Okay, what are the 3 equations of motion? That is V equal to U plus AT. Second one is S equal to UT plus half AT square, and third one is V square minus U square equal to 2AS. Okay, here V is the final velocity. So what is the V here? V is final velocity. What is U here? U is initial velocity, and T already you know that, time. So what is the S? S is the distance traveled. Okay, distance traveled is indicated by S, and A is the acceleration. Okay, these are the terms involved in this 3 equations of motion. Okay, now so we are going to derive the first equation of motion by seeing this graph. Okay, so we can derive this first equation of motion by using this graph. Let us start. How do you derive the equation of motion? The first equation of motion, V equal to U plus AT. Let us start now. So now you see at the time 0 second, our object has some velocity. Okay, so your vehicle has some velocity. So let us say that is u is the initial velocity of your vehicle. Whenever you observe, whenever you start observation, at that time the vehicle velocity is u. After some time, the vehicle velocity increases constantly up to v. After some time t, the vehicle velocity increases to v. Okay, during this time 0 to t seconds. Then how do you find the acceleration? According to definition, what is the acceleration? Acceleration equal to change in velocity. Change in velocity means final velocity value minus initial velocity, that is a equal to v minus u by time. Time is t second, from 0 to t seconds. Okay, so by t you take it here, it will become into t. So at equal to v minus u. So minus u when you take it this side, okay, minus u when you take it this side, it will become plus u, v equal to u plus at. This is what first equation of kinematics, v equal to u plus at, where v is the final velocity, u is the initial velocity, a is the acceleration, and t is the time. Okay, now we are moving to derive the second equation of motion, that is s equal to ut plus of at square, by seeing this graph, by seeing the same graph. Okay, already you know that displacement, so distance, we are going to derive the distance under the velocity time graph. What will you get here? That is displacement or distance. Okay, so this is a line, this is a velocity time graph, this is the blue color line. Okay, under this blue color line, the area under this blue color line, okay, this line OA CDB, okay, like that, it look like as a trapezium. And similarly we have calculated the distance from the previous graph. In the same manner, we can derive the distance formula, that is what s equal to ut plus of at square we can get from this area. Okay, let us start now. Okay, so now you see the area is OABD. So the you select the total area OABD, it look like as trapezium, right? This OABD we can divide it into two, right? Area 1, area 2. Okay, so let us say this is the area 1 and this is the area 2. The area 1 is, area 1 means area of the rectangle OACD. Okay, you take the area from here OACD, and the area of the triangle means the triangle ABC, so upper part. Okay, already you know that what is the area of the rectangle. What is the area of the rectangle? Area of the rectangle is length into breadth. Okay, so you take length is OD and breadth is OA. Okay, so length into breadth, that is length is OD and breadth is OA. Okay, plus area of the triangle, that is also you know that half into base into height. So base you consider here AC, base you consider here AC, into height you consider here BC. Okay, so height you can consider here BC, right? Now from the graph, what the OD value gives you? OD is nothing but this gap gives time value. From here to here, the value of OD is t. What the OA value gives you? OA value is in velocity axis, so OA indicates initial velocity, that is what u. Okay, so t into u plus half of AC. So AC is nothing but AC is equal to OD. Yes or no? AC equal to OD. What is the OD value? OD is nothing but time. Okay, so AC OD both are same. In rectangle, opposite sides are equal, so OD value is equal to AC value. The AC value gives you time, right? So you write here time. BC, BC is how you can get the BC. So BC means, so the BC you consider the total length, that is BD. From this you subtract the CD. Okay, from that you can subtract the CD. Okay, so BC we can write as, from this graph, BC we can write as BD minus CD. Can I write like this? BD minus CD. Okay, so what the BD value gives you? BD means from here to here, BD, this total length, the total length gives the velocity value. See, this total length gives the velocity value. That is the value of OE. OE is equal to BD. The BD value gives you velocity, final velocity. Okay. So BD value we can replace with V, and CD value we can replace with U. You see, this CD is nothing but this is equal to OA. What is the value of OA? OA value is U. Okay. This OA value, CD value, both are same. That indicates initial velocity U. Okay. So now this BC we can write as final velocity minus initial velocity. Okay. Now we are going to derive the distance, right? That is S. So let us say this is a S. S means the area under the velocity time graph gives you distance, that is S. Okay. Now in the previous session, from previous equation, what is the time? So time we can replace with V minus U by A. Okay. The time, the t value, just you replace with V minus U by A. So how we are getting this V minus U by A? From the first equation. Okay, from the first equation, the t value we can write as V minus U by A into U, okay, plus half of V minus U by A into V minus U. Okay, so just you derive this, then you will get the second equation of motion, that is what? S equal to ut plus of at square. Okay, so now you just multiply this. So V into U, how much it is? That is U into V, V into U, both are same, right? So that I am writing as U into V minus U into U. So minus U into U is minus U square by A. Okay. Now here we have V minus U into V minus U. So half you write as it is. V minus U into V minus U is V minus U whole square by A. Okay. So here we have 1 by 2A. So here we have the A. Okay. Just you derive this. Just you derive this. You will get the answer. S equal to ut plus of at square. Now just you going to derive this. Okay. Now you see. Write as it is now. This part, first part you write as it is, that is uv minus u square by a plus this 2 into a you write 2a. Just you expand in the form of this is in the form of a minus b whole square, right? So what is a minus b whole square formula? That is a square. So let us say this is a, this is b. So a square is v square. Okay, a square plus b square minus 2 into a into b minus 2 into a into b, that is 2 into v into u or 2u into v. Okay, so now you check the denominator. Here we have the 2, here we have the a. So make the denominator same. So that to make the denominator same, so what I am doing here, so you just multiply with this first term with into 2 and by 2. Okay, into 2 by 2. So you just make the denominator same. Okay, so to make the denominator same, I am multiplying 2 with numerator and denominator. So now what you will get here? Now what will you get here? Okay, 2 into uv is 2uv minus 2u square by 2a plus v square plus u square minus 2uv by 2a. Okay, so like that you will get. So in the next one, next I am doing here. So s equal to now the denominator value is same, that is 2a to a. So make the denominator value same, that is 2a. Now we can add up the numerators. Okay, so the whatever the numerator in the first term we have, that is you write here 2uv minus 2u square plus v square plus u square minus 2uv. Okay, so here plus 2uv minus 2uv I think get cancel here, right? Okay, 2uv plus 2uv minus 2uv get cancelled. Then u square minus 2u square is how much? That is minus u square. So first you write here v square, then you write minus u square by 2a, that is yes. Okay, so from this graph you we got here s equal to v square minus u square equal to 2as. Okay, from this we can write here v square minus u square equal to 2as. Okay, when you replace the time, then you will get the third equation of motion. This is what third equation of motion. Okay, so to get the second equation of motion, just you replace the term v minus u or t. Okay, v square minus u square equal to 2s. So from this graph we can get third equation of motion, that is what, v square minus u square equal to 2s. Okay, v square minus u square equal to 2s. Okay, now how do you get this s equal to ut plus of 8 square? S equal to ut plus of 8 square. Okay, from the same graph we can get the from this expression. You see, if this expression, you take this expression, okay, you take this expression again, s equal to ut plus of into t into v minus u. Okay, so that means we want to change this as second equation of motion. So second equation of motion is s equal to ut plus of 8 square. Okay, there is no terms of v minus u. Now you do one thing here. From the first equation of motion we know that a equal to v minus u by t. Okay, from this we can write v minus u equal to at. Okay, so now what we are doing here, in the place of v minus u, just you put the at, then you will get the second equation of motion. Okay, so let us try this. So in the place of s equal to ut plus of into t, in the place of v minus u, just you put the at here, at. That's all. You will get your ut plus of into a into t is 8 square. Okay, this is what second equation of motion. Okay, if you replace the time value with v minus u by a, you will get the third equation of motion. If you replace the v minus u with at, then you will get the second equation of motion from this graph. Okay, these are the derivation of kinematics of equation. Okay, so please practice this. This is very important for your exam. Suppose a car is moving on a highway and brakes are applied, which cause an acceleration of minus 4 meter per second square. How much will be the distance traveled by the car before coming to a stop? If the car was moving with a velocity of 54 km per hour, and in second situation it moves with a 108 km per hour, so when the brakes were applied, suppose car is moving with some speed, okay, suddenly you are applying the brake. After applying the brake, the car comes to stop, right? Car before coming to stop, so we need to find the distance traveled by the car. Okay, after applying the brake, it moves up to somewhat distance, right? Before coming to rest, the car moves some distance. Okay, so we need to find out the distance. If car moves with the 54 km per hour, what is its stopping distance? Of the same car, if it is moving with a 108 km per hour, what is its stopping distance? Okay, after applying the brake, right? So just you assume that if car is moving with more speed, after applying the brakes, it covers more distance before coming to rest. Okay, so which car, in which situation the car covers more distance before coming to rest? In the second situation, if cars moves with the more speed, after applying the brake, it covers more distance before coming to rest. Okay, so already they given some things here, right? So I am doing the first situation. Okay, in the first situation they have given the car speed is, initial car speed is 54 km per hour. Always remember that kilometer per hour, you change into meter per second. How do you change the meter per second? Just you multiply with 5 by 18. So 54 into 5 by 18. How much it is? 18 one time, 18 three times. 3 5 is how much? 15. So that is 15 meter per second. This is the initial velocity of the car. Okay, so if car moves with this much of speed, then what is the stopping distance after applying the brake? So after applying the brake, the car is decelerating with the acceleration minus 4 meter per second square. Okay, what is the deceleration of the car? 4 meter per second square. Then acceleration means minus 4 meter per second square. Okay, we have the, after applying the brake, the final velocity of the car becomes 0. The v is the final velocity. After applying the brake, the car comes to rest. That means the velocity of the car is 0. We need to find the s, stopping distance. Okay, so v u a s, which formula we can use? Which formula we can use here? v square minus u square equal to 2as. Okay, use this formula, v square minus u square equal to 2as. From this we can find out the s value, so that we can write v square minus u square by 2a. Use this formula and find out the stopping distance before coming to rest. Okay, now you do it. So what is the v value? V value is 0. Just you substitute the value 0 here. 0 square minus what is the value of your u we got here? 15 square, that is 15 whole square, by 2 into acceleration, that is minus 4. 2 into minus 4. So this we can write as minus 225 by minus 8. So 8 get cancelled. Okay. So now you do the calculation. 225 by 8. 225 by 8, how much you will get here? 28.125 meter. The stopping distance after applying the brake is, when car moves with this much of speed, 54 km per hour, after applying the brake with acceleration minus 4 meter per second square, the car moves up to the distance 28.125 meter, then it stops. Okay, so this is what in the first situation we got the speed of the distance, stopping distance of the car is 28.125 meter. Okay, similarly you do for the second situation. You do for the second situation, if the same car moves with the 108 kilometer per hour, in that case what is its stopping distance? Find out. Okay, the same car, the same car in second situation. So what we are doing, if the same car is moving with the 108 kilometer per hour distance, 108 kilometer per hour speed, 108 kilometer per hour, already you know that 108 kilometer per hour, just you change into meter per second. For that what we are doing, we are multiplying this 108 with 5 by 18. Okay, you already you know that 18 table, 18 one time, 18 six times. Okay, 6 into 8 is 108, 6 5 is 30 meter per second. Okay, u equal to 30 meter per second. Okay, the same values you can substitute here. Acceleration is minus 4 meter per second square, and the final velocity of the car becomes 0 after applying the brake. Then what is its stopping distance before coming to rest? Okay, so the same formula we can use here, s equal to v square minus u square by 2a. Okay, so here v square is 0 and u square value is how much it is? 30 square. 30 square by 2 into a. 2 into a is minus 4. 2 into minus 4. Okay, so 30 square minus is there here. 30 square is the 900. 2 into minus 4 is minus 8. Okay, just to you cancel it. Just you calculate this 900 by 8. How much you will get here? 900 by 8 you will get here 112.5 meter. How much it is? 112.5 meter. This is your answer. Okay, if car moves with less speed, it moves up to 28.125 meter distance and then it stops. If car moves with 108 kilometer per hour speed, after applying the brake, it moves up to the distance 112.5 meter and then it stops. Okay, so in this way we can find out the stopping distance by using the equation of motion. Come to here, next one is uniform circular motion. So what do you mean by uniform circular motion? When object moves in a circle at constant speed, if direction always changes, so velocity always changes. Now you see motion in circular path. Now you see when object moves with a constant speed, so everywhere you see the direction is changes. Okay, the direction of particle on the circle is nothing but the tangent drawn from the circle gives the velocity of the particle at that point. Okay, now you see everywhere the direction of the particle is changing, but the particles moving with constant speed. In speed is the scalar quantity, velocity is the vector quantity. While considering about velocity, the velocity direction is always changing, but its value is same, magnitude is same, but direction is changing. So in uniform circular motion, it moves with constant speed, but it changes the direction. Okay, it's changed the direction. The object moves at constant speed, but direction changes continuously. Example: Earth orbiting the sun, the fan blades, merry-go-round. These all are examples for the uniform circular motion, right? So this is always accelerating. How do you say that is always accelerating? So in circular path, if particle is moving in the circular path, it's always changes its direction. Its direction is changing means velocity also changing. So changing velocity means this object is always accelerating. That means if direction of the velocity changes, the velocity is changing. If velocity is changing means it is always accelerating. Next, tangential velocity. What do you mean by tangential velocity? Velocity at any point is a tangent to the circle at that point. Suppose when particle comes to here, what is its direction? So its direction of the particle gives the tangent, the drawn to the circle at that point. Okay. So suppose when particle is comes to here, it moves up to this direction. Okay. Anytime, so the direction is changing on the circular path. So when you draw the tangent to that particle, it gives the direction of the velocity of the particle. Okay, so in this way, when particle is moving in uniform circular motion, that means the speed is constant but direction is changing. If direction is changing means the velocity is changing. Velocity is changing means that is accelerating. How do you find the direction of that velocity? The tangent drawn to that circle gives the direction of that particle at that instant. Okay. Now you see, come to your motion in plane. So motion in plane means now we are discussed about motion in a straight line. If object moves in one dimension, that is gives a motion in straight line. That is motion in one dimension. Okay, motion in plane means it covers two dimensions, x-axis as well as y-axis. The first example is example for the motion in straight line. But the second example, so the football player, okay, he kick the ball, then the ball moves in the projectile path. Projectile path means it covers both the distance. Okay, suppose this is the ball, it moves y-axis as well as it covers x-axis. So x-axis also it is moving, y-axis also it is changing. Means if object covers both the dimension, so this is example for the two-dimensional motion. The two-dimensional motion is an example for the motion in a plane, right? So motion in two dimension means car overtaking, kicked ball, satellite orbit. All these are examples for the motion in two dimension. And in circular motion, distance traveled equal to arc length, displacement equal to straight line chord. Okay. Okay, so how do you find the distance and displacement while particle is moving in the circular path? For example, if particle is moving in circular path like this, a particle is moving in circular path, how do you find the distance? Distance means full rotation. Suppose our particle starts from the A, again it reaches to the A. That means the particle rotates one full rotation. Means circumference of this path gives you distance. Okay, that is 2 pi r. But displacement means 0. The initial and final point both are coinciding. So particle starts from the A, again it reaches to the A. Means the final part and initial part both are coinciding, means in this case the displacement value becomes 0. For example, if particle rotates, if it starts to the A, again it reaches to the B, opposite to the A. So in this case, what is your distance and what is your displacement? So particle rotates 1.5 rotation, or particle rotation half of the rotation. Let us say the particle is rotates half of the rotation. Particle moves from A to B. Okay, then half of the circumference, that is pi r. So circumference of the circle is 2 pi r. Half of the circumference is a pi r. The pi r gives the distance, right? The distance is the pi r. Then how do you get the displacement? While calculating the displacement, remember you have to join the initial point and final point. So initial point is A and final point is B. The gap between A and B. So what it gives you? Diameter. The diameter of the circle gives you displacement. Okay. So displacement, how do you get for off rotation on circular path? So that is diameter of the circle. So while calculating the displacement, just you have to see initial point and final point. You join the point and according to that you calculate. That's all. Okay. So in this way we can calculate the distance and displacement when particle is moving in circular path. Okay. So move on to the next one, tangent to the circle. Velocity is always tangent to the circle, right? So the tangent at any point on a circle is perpendicular to the radius at that point. Okay. So just you see this, when you draw the one line from the radius, This is what tangent means the line which does the circle at only one point is called as the tangent. Okay, when you draw the radius, this is what radius, and this is tangent. The angle between the radius is tangent is always 90 degrees. Okay, the tangent at any point of the circle is perpendicular to the radius at that point, right? So move on to the next point. So average speed gives you total distance by time, and the SI unit of the average speed is meter per second. Average velocity is displacement by time, and unit is meter per second. And average acceleration is change in velocity by time, v minus u by t. SI unit for acceleration is meter per second square. So this is a v equal to u plus at kinematic equation 1, first equation of kinematic. S equal to ut plus half at square, second equation of kinematic. And v square equal to u square plus 2as, this is third equation of kinematic. And the circumference of the circle is 2 pi r. Okay, the SI unit is meter. Okay, thank you, your lesson is over. If you like this video, please subscribe. Thank you for watching. Bye.